Yeah, we're live. According to YouTube.
Okay, so last on-site talk for the day. I'll try to cover a bit more specific, maybe more technical aspects of Easy. So other stuff we're doing beyond just making that publicly available software stack, getting it out there and making sure it works well. So three things. The last one will be quite short. But one thing is about the Easy Test Suite. So we're using Reframe to make sure those installations that we provide work, keep working, and that you also at your site can check, are the installations that Easy provide, are they working for you as well? So this has a bunch of uses. A little bit about the GPU support, the NVIDIA GPU support, I should say. We don't support any GPUs just yet in Easy. That is something we're definitely going to work on in the next couple of months, but it's not there yet. And then a little bit about how you can use Easy and GitHub Actions. And to me, that's a very interesting use case. And we're seeing this in the wild already. So that's quite interesting. So first of all, start with the Easy Test Suite. So what do we want to do here? Well, we want to make sure that what we provide actually works. So we don't pretend we compiled and here's the binary and now you're on your own. Before we push it into Easy, we want to do a check to make sure it's actually not only running, but producing valid results. And eventually, we're not there yet, but also keeping an eye on performance. Is it performing the way it should? Does it keep performing the way it should? If we make any changes over time, we shouldn't see any serious performance regressions either. Yeah, so we want to provide more insight into performance, like I just said. We want to do that both single nodes. That's definitely what we're going to start with, but also multi-node. So stuff that should scale, like OpenFOAM, like GROMACS. If it scales today, should still scale tomorrow if we're making any changes to the compat layer, for example, if you have to update glibc because of security issues, that shouldn't kill the performance. Also, maybe specifically the way Easy is available or is integrated on your system, maybe there's some details there that have a serious effect on performance. That would be good to know. In the end, we want to get to a situation where we not only keep an eye on these performance numbers, but we publish them as well. Because very often people, even if you're hand installing something yourself and it runs, you're quite happy. And then you do some kind of benchmark test. And for GROMACS, you say you get 1 nanosecond per day of performance, how fast the simulation is. Is that good for your hardware? Is that bad? Like, should it be 10? Or did you somehow manage to make it 10 times faster than other people? How do you know, right? You have nobody who can really give you even a ballpark figure of what it should be, probably. It's not that easy to find numbers like that. That's something we would like to try and do as well, at least for commonly used software. OpenFOAM is definitely one of those as well. Like, how fast should you be able to run 100 time steps? What's reasonable to expect for your hardware? Of course, it's very tied to the hardware, but at least ballpark, you should be able to figure out how far off you are. Yeah, so getting those numbers, then we'll need to talk to the developers, the real experts of the software, like what should we expect for this type of hardware? Give us some numbers, and then we'll check if we can actually meet that performance with the installations we provide through Easy. So those are all a bit of the goals. So how are we doing that? Well, we looked around. It's clear that many HPC sites are already looking at Reframe. So that was like was pretty clear that was going to be a good goal for this. What's also clear is that, okay, we have this common software stack, but we don't really know on what type of systems it's going to be used. For just running the software, that's not too big of a problem. Like, we have the CPU detection, that's good enough to get it running. But if you want to get tests running, you need to know, okay, how many cores do I have? What's the amount of memory per core? Maybe how is that software exposed? It doesn't need to come in through Easy. The test suite also works through basically any software stack, although we do make assumptions that it's installed with EasyBuild, at least currently. So we wanted to make a test suite that is portable, that you can just take the test suite to your system, you configure it for your system. So which partition should it submit jobs to? What kind of number of cores can it expect? How much memory is available? maybe some details on doing the job submission itself, but there should be no need to touch the tests or modify them or implement your own derived tests from that to make it work. So that's typically what people have been doing in Reframe. Many people are sitting on their own test suite, and unless you're very, very careful, it's very difficult to share that with other people. From the very start of this, that was definitely our goal. Like, we want to build a community test suite, let's say, which can be used across different systems. We also definitely want to go beyond what EasyBuild already does in terms of testing. So it does tests during the build. That's very good. We have a sanity check for most stuff as well, which acts like smoke tests, also at the end of the installation. But then when you take that installation and you move it to somewhere else, like we often do with Easy, maybe you install in our Debian build container and then you run it on Rocky Linux. Does that still work? And that's okay. EasyBuild does some things there, but we definitely want to make sure we can do a good job in terms of testing. We also separate between different types of tests. I won't spend too much time on that. There's actually a pretty extensive document that we wrote up in the scope of the multiscale project here, which explains what all of these are and how we think they are different. Some of the terminology here is a bit hazy as well. But in the end, yeah, we're looking at application tests that basically make sure that the software that we give is working on your system as well. Periodic tests as well. So over time, weekly, maybe daily, we're going to rerun the same tests over and over again, not only to make sure they keep working, but also so we can have performance numbers over time and see that that's still working. So that's, I would say, pretty ambitious. But we're now already at a point where we think we know what we should be doing and how we should be implementing these tests. So in the first year of the multiscale Center of Excellence, this is one of the tasks, and there's actually quite a bit of person months going to this. The big, well, let's say the partner who's supposed to drive this effort and is really driving this effort is SURF in the Netherlands. So they are mainly responsible for this task. We've had a lot of meetings on this in 2023, like starting from the idea, like what do we want to do? How do we get started? Who does what first? We started with GROMACS, and I think we worked for 6 months on a single GROMACS test, just kept iterating over it, running it on different systems, realizing that, okay, we made some assumptions here that are not valid on the other system, so we have to do things a little bit differently. And it took us a very long time to get an initial test that we were happy enough with to call it portable. And that was the starting point of the test suite. Today, we still only have a limited number of tests, GROMACS, TensorFlow, and OZU micro benchmarks. But the TensorFlow and the OZU tests have been a lot quicker to implement, because based on all the work we did for GROMACS and all the functionality that the test suite provides, it gives you hooks, it gives you functions that you can call out to figure out things or to do things based on the configuration. So all of that is reusable, and yeah, thanks to that effort we put in GROMACS, that has become a lot easier. Today we're also using the test suite, and maybe you saw that popping up in Pedro's demo. When you add new software into Easy through that pull request mechanism, it will do the builds, but after doing the builds, it will also rerun the Easy test suite. It does that currently in a pretty stupid way. It just reruns the tests for all the applications, which doesn't make sense, because if you're not adding another version of the application, there's really no point in running the tests. But that's the first step for us to integrate that test suite into that pipeline. Eventually, we'll make sure that only the tests that are relevant are actually run, so that only the tests for the applications being added in that pull request are being run. Right now, it's not big enough, so it runs in a handful of minutes, so we don't really care too much for now. Usually, there's multiple tests for each of the applications or benchmarks that we have a test for, so it's not a single input or a single run of that application, but it's multiple ones, and you can pick and choose which ones you want to run. Maybe all of them, maybe only the ones that don't need a lot of resources, or only the quick tests, or maybe only the larger tests that you want to typically run on multiple nodes. So you can choose the sizes and the scalability or amount of resources you want to use for running these tests. This is going to be clear when I do the demo as well, but one thing you need to do to start using the test suite is to create a configuration file that tells the test suite everything that it needs to know about your system. That's a one-time pain, essentially. So if you're doing that right from the get-go, you should only do that once. And Oak isn't fully agreeing with me here, but we can have a discussion on that. But so we try to only get all the information from the configuration file and not hard code anything in the tests. Yeah, Sam? Yeah. So we do rely a bit, and optionally we rely on the auto detection that Reframe can do. So detect how many cores, what type of CPU you have. So Reframe has some features on that as well. I think we even recommend that in our documentation to use that. But if it gets things wrong, or if that's not working for whatever reason, you can override it and just hard specify it in the configuration file. Because typically your partitions don't really change over time. And typically you also know what's there. So we'll show some of that in a bit. We're already running the test suite, I think, daily on 3 or 4 different systems. On the AWS cluster, where the bot is also running for doing these builds, we have a cron job that submits the test suite or submits all the tests in the test suite at least once a day. And we try to make sure that doesn't break down over time. It shouldn't. But also on some of the bigger Euro HPC systems, like on Vega in Slovenia, and also a system in Ghent and at Surf, the test suite is being run basically on a daily basis. So we're already using this for periodic testing, even though we have a limited number of tests. So we're building up the experience there as well and seeing how that goes. So a lot of work has already been done. We're now, I would say the biggest focus is now is adding more tests. So we have open pull requests for at least most of those. For OpenFOAM, it's not an open pull request yet, but it's a work in progress. So Satish at Surf is working on this. Same thing for Espresso, I think. I don't think there's an open PR for it yet. But for lamps, for Quantum Espresso, and for CP2K, so all scientific applications, those have an open pull request with a test implementation already there. Most of these are in a state that they're ready for review and testing by others, and so we'll do some iterating, or at least have multiple people run the tests on their side before we call it a success and include it in a test suite. But it's clear that for implementing these tests, that all the groundwork we've done with those initial couple of tests has been very useful. So we can keep these implementations quite short, and yet we do get a portable test out of that. What we're now starting to look at, and actually have to look at in the scope of multiscale, is looking at getting these performance reference numbers. So what kind of performance should we get expecting, and how do you get the relevant performance numbers for a particular system, because it's very much tied to the system. So we're thinking about collecting those numbers somehow and storing them so you can easily get them back dynamically from the test. So if you're running at the Hortan system in Ghent, for example, that from the test you can ask, give me the performance reference number for the system I'm currently running on, and it just gets it from a YAML file or a JSON file or whatever. So you don't have to hard code this in the tests. All the tests are implemented in Python in Reframe. That's very good because you can do lots of dynamic stuff while the test is being run or while the test is being prepared. Eventually, and at least for the systems we can, we'll make that data public as well. We'll have a public dashboard that shows all the results we've been getting over time for these periodic systems. All the systems, typically the ones that we manage, because for those we don't have to really ask anyone for permission to publish that data. For Euro HPC systems like Vega, that's probably going to be a bit more difficult. They may not be very happy if we publicly announce that running GROMACS on their system is 10 times slower than it is on another system. Yeah, we'll see how that goes. Next to actual applications, we're also looking at more low-level stuff. For example, OpenBlast. Maybe we want to rerun the OpenBlast test suite or specific OpenBlast tests through the test suite as well. That could be interesting to have a zoomed-in view on some certain aspects of applications. Yeah.
Would you be open to accepting performance results from other sites?
Oh yeah,
in an
definitely.
easy way?
Yeah. Oh, definitely. So that's something we definitely want to facilitate. So if you're interested in running the Easy Test Suite and you're happy to give us those numbers, we'll probably set up some pull request mechanism that you can give us that data file, and then that at least gives people some ballpark idea, and we'll probably tie that with some hardware information, like on what type of system was this collected. That's already enough to say, should I be getting 1 nanosecond per day or 10 nanoseconds per day? That would already be useful. And doing that in a structured way, of course. And so, yeah. And of course, documenting it better. Actually, the documentation is already quite okay, I would say, at least for using the test suite. There's definitely documentation missing on implementing additional tests. So what do you have to keep an eye out for? What's available in terms of functionality in the test suite that makes that easier. I guess we want to build up some more experience first, implementing additional tests, and then we'll hopefully that will get translated into documentation as well. In the end, and in the not so distant future, we'll probably even give like tutorials on this as well. So how you can implement portable tests with Reframe. And we're talking to Veselius and the Reframe developers as well on this on a regular basis. We want to make this a conversation because they are the experts, and very often we are maybe doing things old-fashioned way where Reframe has new features that we could or should be using. Veselius has definitely been mentioning some of these things yesterday in his talk. Contributors so far, so it's mostly developed in the scope of multiscale with four partners involved. Surf is definitely driving a good amount of the development. We at Ghent are spending quite a bit of time on it as well. Mainly Lara has been doing that. I'm mostly there in the meetings, pretending I'm going to do stuff and then not doing anything at all. And also Groningen and University of Barcelona, so Alan, are involved in this. Is that right? Yeah, okay. But we also already have external contributors, and especially Sam from the Vrije Universiteit Brussels has been joining our meetings for months now, for a pretty long time already, I think. So we have test suite sync meetings every 2 weeks, which is quite frequent. But those conversations have been very interesting, and a lot of back and forth, like how could we do this? And then we try to redistribute the work a bit. Sam has basically joined that voluntarily, so he's not involved in the multiscale project, but that has been very helpful as well. He's been doing the CP2K test, for example, and lots of other things as well. And also from within CCAM, so CCAM is not a partner themselves, they're a consortium of partners, but there are people working at CCAM directly, and we got a contribution from there for Quantum Espresso, a test for Quantum Espresso. So we're also already seeing this being adopted, or at least seeing interest by other sites as well, even beyond the program, the project. We wrote up a deliverable after the first year of the multiscale Center of Excellence, a plan for the design of a portable test suite. So there we're mostly outlining the plan we have based on the work we did with GrowMax and based on the experience we have with GrowMax. Like, what do you need to look out for when implementing portable tests? And a lot of blah, blah around that. So it's like a 10-page document or something. But it is very interesting if you're interested, even in implementing your own test suite. There's a lot of stuff there that you may not be aware of or may overlook initially when you start working on this effort. And it's well documented, installation, configuration, usage. I'll try to do some of that right now in the easy documentation. Yeah, okay. So there's a whole section here in the documentation on the test suite. This is just the overview page, so we're using Reframe. Where you should definitely start with the installation and configuration part, because there are some important details here. You'll need a pretty recent version of Reframe, because we rely on some features from there. You'll need Python 3.6. We don't support anything older than that. It's already pretty old. And you need to make sure you have a Reframe installation that includes the HPC testlib component. So depending on how you install Reframe, you may not actually get this part. So you definitely want to make sure that's there, and you can check that by doing this type of import test. If this doesn't work, you're missing that component, and the test suite is not going to, or at least some of the tests in the test suite are not going to work. If you install Reframe through EasyBuild, you're getting that component. If you get it from Easy, so we include reframe in Easy, it's also there. So that's definitely an easy way to get started. Version requirement, that's all details. Then to install it, you can pip install it straight from GitHub. We also, do we actually have releases on PyPy? I forgot. An old version. Yeah, we didn't publish the new version. Ooh, okay. Yeah, so for now, get it from GitHub to install it, or just clone the repo and then set your Python path. That's actually good enough. You don't really need to do more. To check if that's working, do an import of the easy.test suite package, and that should work. To installing it shouldn't be very difficult. Configuring it, this is a bit of homework, and it's important that you read through this and make sure you're getting the details right. You need to give us a configuration file, and we have, I'm not sure why this is not a link, it should be, but in the GitHub repo, we have example configuration files, which are actually used in practice. We have one for Vega, for example. This is the one we're actually using on Vega. Same for Carolina, another Euro HPC system. We have one for VSC at Ghent, for Hortense at Ghent, for Snellius at Surf. We don't have one for the VUB. No, you're running on Hortense mostly, I guess. Yeah. Okay. Yeah. So we could add more, but these are similar enough that I'm not sure if additional ones would be useful. If you want to give us your configuration file by means of another example, it's definitely welcome. We also have the configuration file that we use in here in Magic Castle in our AWS cluster. So you can definitely use these for inspiration. But this is also well covered here in the documentation, what you need to do. So you need some configuration file, and you need to configure reframe to also use it. For example, by setting this environment variable, or by passing that as an option to the reframe command if you want to keep doing that. You need to make sure that reframe can find the tests in the test suite as well. So you need to set the search path, and you want to make sure it searches recursively through that directory. So just set that and then forget about it. And if you want to control where reframe stores all the files it produces, the easy way to do that is set this RFM prefix environment variable to any directory where you have write access to, and then reframe will dump all the results in there and in a whole bunch of subdirectories. Yeah, so do make sure you get these things right. The biggest one, of course, is the configuration file. So there you'll have to do some homework. We have a separate page on that with all the details. I'm not going to step through this, but it looks something like this, where you'd set up a site configuration Python dictionary. So this is basically Python syntax. That means you can import stuff from the test suite. So it makes whatever is common in terms of logging, for example, or in terms of making sure that easy is actually initialized when it should be here via prepare command. So we already give you a bunch of things that can be useful even in the configuration file. But typically it says I have a CPU partition and I want to use this as a launcher for or distributed runs. It's a Slurm partition. This is options, extra options you want to give when you're submitting, and so on. And then there's no core counts here. That basically means we're relying on the auto detection that reframe does. So if it doesn't see core counts in here, the first thing it will do is launch an auto detection job and basically fill in the blanks for you. So this is not too daunting. This is the most easy we can make it, I think. You give it a single configuration file in Python syntax for reframe. Lots of details here on how to do that. And then you should be good to go and actually run the test suite. Let's show an actual example of that in the wild. So the one for Hortense here on our system, which was actually created by Sam, I think, originally, and then we did some back and forth on that for some details. So you can see here, for example, this is the partition we'll be using in the demo, a CPU roam partition. Here we do hard code all the processor info because we had some issues with auto detection at some point, and we just made sure that it's actually correct what's there. Our system is a bit quirky in some sense. We have a bit of a strange way of exposing the partitions to users, maybe through modules. So people pick a partition by swapping to a particular module. But reframe doesn't really use that. It just talks straight to Slurm and passes it the right partition option to do that submission. Yeah. Here we're telling it this is a CPU only partition, so it only has the CPU feature. There's GPU partitions on the system as well. There you'll see it has either only the GPU feature, so this basically tells reframe only submit GPU tests to this, don't submit CPU only tests, but you can add it both the CPU and GPU feature, and then it will do CPU only tests also on GPU nodes. Maybe you have internal policies not to do that, but you're free to configure reframe to actually do that. And here we're already preparing for also supporting AMD, so we're telling it it's an NVIDIA GPU, not an AMD GPU. We have a special launcher here as well, but I'm not going to go into that. So we're not using MPI run, but we're using a wrapper script for that, which needs an extra module. So yeah, there's actually a lot of things you can do in reframe to make that possible. If you look at the surf one, it's going to look very, very similar. Just the details are going to be different. Yeah, there's even way more documentation here. So something that Snelli's at Surf has a bit special is it doesn't allow partitions to the submissions to the GPU partition without requesting at least one GPU. So if you're not asking for the GPU, you just get an error when you do the submission. That's not the case in Ghent, but it is here. So that's why some things here are extra in the configuration file. So we give you a lot of flexibility here for the things you need to do. Yeah, you actually can do this. And here they are relying on the auto detection. So here there's no CPU count numbers in here because reframe seems to be doing a good job in auto detecting them. So hopefully that's not too daunting to get started. If people have ideas on how we can make this even easier, it's definitely welcome. To some extent, this file can be generated. You can probably ask Slurm, what do you have? And then you can kickstart that configuration file as well. We haven't done that, but there could be some tooling around this as well, if that's useful. So assuming that configuration file is in place and is correct, you can start using the test suite. So you basically just pip install it or you git clone it, and then you're good to go. Let's see. I've done this here in the script because I was just making sure I don't mess things up. I have to do some cleanup in my environment as well to make sure I actually also only want to expose the easy modules to reframe in this case, not the ones we have locally, because then it becomes a bit difficult. So that's why I essentially initialize the easy environment here and then load reframe from there. And I'm only seeing the easy modules, nothing else. Then I'm making sure I'm in the test suite directory, so the cloned GitHub repository. And then doing the minimal configuration here, I'm telling it which configuration file to use. I'm making sure it can find all the tests in the easy test suite. And then here I'm already pinning it down a bit. So this is telling it only submit jobs to the CPU Rome partition of Hortense. So this has to match with what's in the configuration file, or reframe will scream at you. And I'm telling it put all the results in this directory, which doesn't exist yet, so it will have to create that. In this particular case, let me start with just listing the tests. I'm pinning it down to only TensorFlow tests. So if you do a -- name with the name of a software, name of a module, it will only run tests that are available for that particular module. So I'm only focusing on TensorFlow here. I'm also telling it only use the 4-course scale. So these are tags that we've defined. Jumping to the documentation, we've defined a set of tags here, which we call scale tags, to tell reframe how many cores it can use. Let me make this a bit bigger. So we have a 1-core case, which is very obvious, 2 cores, 4 cores. And then let's skip these 2 for now. Then we do like 1/8 of a node, 1/4 of a node, half a node, and full node. So you can already see here we're trying to be a bit neutral in terms of how many cores are available per node. We don't want to do 4, 5, 6, and then up to infinity. So want to make sure that kind of makes sense. This also applies to GPUs. So if you have 4 GPUs and you do a quarter node, you'll get 1 GPU. If you have 8 GPUs and you do a quarter node, you'll get 2 GPUs. So that also applies to both cores and GPUs. Here, this is a bit of a special case. This says use 1 CPU core per node and do 2 nodes. So try to get 2 cores, but on separate nodes. That's not always allowed. It depends a bit on your Slurm configuration, whether that makes sense or not. But you can basically pick the tags that make sense for you or the ones that you're most interested in. And then, of course, we have multiple nodes as well for the stuff that makes sense to run across multiple nodes. For now, it's limited to 16, but we can add more tags if that makes sense. All right, and reframe actually allows you to use multiple tags at once. Just the syntax is a bit weird. If you want to say submit tests on both 1 and 2 cores, you have to do an or logical or. Or if you say I want to use multiple tags, but you have to combine them to filter the tests. So here we do 1 scale tag, 1 core, and an additional tag. So we have a CI tag as well, which is explained here. This is just to filter out the smaller tests, the one that runs in seconds typically. So here we say only run the tests tagged with CI and only run them on a single core. So that's when you combine things, and then you have to use the tag option twice. That's a reframe quirk. That's not up to us. So that's the scale thing. That's also why in this case, I'm using the CI tag as an extra option here. And then we just pass this all down to reframe. This is how we actually run the test suite. We just run reframe, you give it the right options in the right configuration, and it should do something. So let's start by running this demo script. It's not actually going to do any test runs now. It's just going to list which tests it has available. So you'll see a bunch of output now, because one thing the script will first do is initialize Easy. We only want to get modules from Easy. There's currently 1 TensorFlow module available in Easy. So we should be seeing exactly 1 test being generated, because we filtered it down to, what did I have the filter set to? 4 cores. So that means we're doing 1 scale of the test, and it's also tagged down to only filter the tests that are tagged with CI that are small enough to run quickly. So that's what I'm getting here. I'm getting 1 module, and I'm getting it only with 1 scale. So if I change the scale to, let's say, do 2 cores or 1 or 4 cores, then I'll get 2 tests, because it will do the will submit the test for the single TensorFlow module twice, once for 2 cores, once for 4 cores. And you can play with this all you want. So it takes into account the available modules. I didn't give it that anywhere. It just detected that based on module avail, and then it generates tests for each of these things. That's listing the tests. Now this thing actually doesn't take into account the configuration fully yet. So it doesn't actually look at this at all, or it doesn't actually look at the configuration file at all. If you do a dry run, it will, and things will look a little bit differently, I think. So now, rather than doing a reframe list, I'm doing a reframe dry run. And then it is going to look at that configuration file and which partition you may have selected for doing the submissions. So here, this looks already a little bit differently. It's still generating 2 tests, but here you see that partition information is in there already. And this to show you what will happen if I change this to just say run tests on Hortense and don't specify any partition, then it's going to try to submit jobs to each of the partitions I have on Hortense, and you'll see a lot more tests being generated. So rather than 2, it should be 10 or 12. How many partitions do we have? I don't even know. We have CPU Rome with more memory, CPU Milan, GPU. Yeah, 2 GPU partitions, and then I overlooked something, but fine. So you see it's generating tests for each of the partitions now, without actually doing anything, so it's a driver. Yeah. Let's put that back, because actually on our system, it doesn't fully work correctly if you tell it to submit to different partitions, but that's a quirk on our end. So let's put it back, and rather than doing dry run, we'll actually make it run. And I was testing this just a couple of minutes ago. It is running, but it is doing something a bit strange, which I don't fully understand. So when reframe runs the test, it generates tests, it generates test scripts, and then it just submits them as Slurm jobs. So you'll see it hanging here. But if I look at another terminal and run SQ, you'll see it has just submitted 2 jobs here that correspond to the different configurations we have. And now you can also go in here. So we had it configured to, so I'm in the same directory as I was in here. And in here, you'll find that output directory, so the RFM prefix that I specified. And here you start seeing the results. So there's logs in here of each reframe run. So the last one is this one. And then here you can check how things are going. And now you can see stuff is happening here. Now, what I'm not entirely sure about is it keeps doing the same thing over and over again. It's entering stage run again and again and again. I'm not sure why that is.
Yeah.
So every 5 seconds or something. Yeah, I haven't seen the jobs finished, but fine. Tests are being generated, Slurm jobs are being submitted, and they should be working. I may have overlooked something.
It's checking the state of
Yeah.
the jobs.
Yeah.
Still running.
Yeah, it takes a while, but it shouldn't be. Okay, it's only 2 or 4 cores, so it's not going to be really fast. The TensorFlow thing should run pretty quickly. Yeah. Anyway, let's see how it does.
If you go to the output directly instead of look at the actual.
Yeah, I can check there, I guess. But so you'll see a bunch of directories here, logs, stage. That's where it generates the working directories for the jobs. So you'll see that. Why is it doing Milan? For the dry run. Okay. Yeah, this was what I was doing before. Okay, so here, this is the actual stuff where things are happening, I guess. So it should be doing in here. So you see Reframe does a lot of stuff in the background. You get these hashes as well. So that's like the full test configuration, a bit like what Spec does when you do installations. So I guess that's where they got the inspiration. In here, this looks pretty empty still. I'm not quite sure if it's actually doing something useful. So that's a very good demo, I guess. But fine. You should definitely try and do this at your site, see if you can get it running. And like I mentioned, I'm now consuming the software that's available in Easy. But if you have TensorFlow installations yourself, or GROMACS, or OZU macro benchmarks, you can run the test suite on top of that as well. And there are some assumptions in the tests, but as long as you've done the installations with EasyBuild, it should be fine. If you've done them in another way, I'm not 100% sure the tests will work. But even there, that's something we can work on, because we actually do want to be independent of that as well. All right, yeah. Again, the documentation has further examples and lots of details if there's some things you want to do. Any questions on that? Yeah, Jörg, can you pass the mic?
That is actually quite interesting, and I think it is interesting for a different reason as well. If you go out to vendor and say, okay, I want to purchase a new cluster, you basically could say, that is exactly what you're doing, and you're providing me the results, because here we've got a list of already existing clusters. How much better are you? Instead of us going and said, okay, we want you to run that test, and they say, oh yeah, it's not a problem. We do our own installation because we handcraft things in there.
They could still do that. They could still optimize their software installations, but at least the tests could be fixed. Like, we want you to run this, right? And you can tune your software all you want, but this is the test you're running on top of it, and it should be working.
Yeah, but if you use the Easy software stack, then they can't do it.
Sure.
That is what I'm
then
after.
then you're limiting them to
because then you've got exactly one binary for a particular architecture, and then you get reliable numbers instead of having, I've got fine-tuned my GROMACS or whatever.
So to some extent, this kind of effort is also only really possible because we have a common software stack, right? Because even if stuff is installed through EasyBuild, things are maybe still going to be different enough that you'll run into trouble when trying to share tests across these systems. At least with Easy, you have some kind of common ground. And, Okay.
The problem with these tests are probably that they only work with the flat naming scheme. Because in the hierarchical one, you have to specify which toolchain first and then load the module.
Yeah, we're aware of,
Sometimes.
we had some discussions on that, I think. But up until now, we haven't found anyone that has a hierarchical naming scheme. You do, so this is definitely something we want to try and fix. Yeah,
I can't remember if Reframe was smart enough to actually use models.
yeah,
while
it's
they're
actually
not.
mostly on the reframe side that this is an
Yeah,
issue.
that's where the problem is.
How it
I can't
discovers the
remember.
modules. Yeah.
I think I actually have to. My tests always load specified toolchain and module.
But it should be fixable, right? Yeah. Reframe has something like plugins or hooks as well, where you can customize some of the things it does. Maybe for module discovery, you'll need to implement your own hook or.
I think I have.
No.
Issue on this. It's what you're saying.
So yeah, this has been very interesting, this effort. It's an ongoing effort as well. We're not even close to done. But we hope this could become a community kind of thing as well. That's also something Vaselios mentioned yesterday, is that they have an HPC test lib now. They want to pull it out so you can install it standalone. But the tests in there basically always need like deriving to make them work on your system. So they're not really portable the way they're done now. So also for them, this is a very interesting effort. Right, if there's no questions, I'll power on. This is going to be very interesting because I didn't prepare this very well. But the NVIDIA GPU support we have in EasyBuild. So we don't have a lot of GPU support yet because there's a couple of open questions there. When we do software installations, we do it again and again for a number of different CPU targets. If you factor in GPUs, there's different generations of GPUs as well. And also there, like, where do you put the installations? How specific do you make them to particular GPUs, or do you do fat builds that work anywhere? Apparently that doesn't work for some software, like for lamps, I think. You cannot make a fat lamps build. It has to be specific for a particular type of CPU. So how do we integrate it in Easy? That we haven't fully figured that out yet. But we've done a lot of groundwork here to support NVIDIA GPUs. We have CUDA samples and OZU micro benchmarks with CUDA support enabled included in Easy. So at least there's GPU workloads there. And it took us quite a bit of time to actually make this work, because I don't have this graph here anymore, but remember the layered structure that Lara showed with like software layer, compact layer, fast system layer. And then you had a pillar next to it with your host operating system. For GPU, you need to get the GPU drivers from the host operating system. We cannot ship these through Easy. They're too much tied to the Linux kernel being run on the client. So we need to get them from there. And for Easy, that's a problem, because that's problem number one here. We don't know where these driver libraries are. Like, there's no fixed path where they are, especially across operating systems. We have to assume, we have to query something to actually figure out where they are. So we cannot ship those in Easy, and we don't know upfront where they're going to be. And we need to expose the location somehow into Easy. Another problem we have is that when you're shipping software that relies on a CUDA runtime, is that you need a CUDA runtime in Easy. That's allowed. But if you do a CUDA installation, it includes the runtime, but also the NVCC compiler, for example. And that's a part we're not allowed to redistribute. So the EULA says, you cannot copy this and make it publicly available. It's illegal. So there's export control kind of stuff. We can only do that for the runtime library. So when we install CUDA in Easy, and if you do a module avail in Easy, you'll see CUDA there. But what you're getting there is only the runtime parts, not the compiler. That means if you want to build your own GPU software on top of what's available in Easy already, you'll have to install a full CUDA installation first on the side, and then basically use that to do the builds and only get the runtime from Easy. So to fix these issues, we've done quite a bit of work, or mostly Alan at the University of Barcelona has done quite a bit of work to script this up to make this as easy as possible. And we have very detailed documentation available as well. So we give you two scripts. One script is link NVIDIA host libraries This basically figures out from the host where the GPU driver libraries are, what that path is, then it creates symbolic links in this host injections path. So the host injections path, Oka was showing this very briefly as well. And let's see if I can bring that up here. Let me log in to a node where I can actually play around a bit. I'm just accessing a node in Ghent where I'm still in the container here from before. Let me restart that. Right, so in here, I'm in an environment where I have access to an NVIDIA A2 GPU. And if I want to use this through EasyBuild, let me do a module on use of everything I have, because I want to make sure I only pick up stuff from EasyBuild. Right. So I can check here what's there in terms of CUDA software. And it's going to tell me you have a CUDA here, which is actually only the CUDA runtime, not the full installation. I have a CUDA samples module and also micro benchmarks and then some other CUDA related stuff. So let's stick to just the CUDA samples. In this case, load that module. And here, Elmo will scream at me and said, oh, let me get the zoom crap out of the way. It says you requested to load CUDA samples that relies on the CUDA runtime. Okay, we're getting that from Easy, but also the driver libraries. And it just says, you haven't done your homework. You'll have to read the documentation first because I don't know where these driver libraries are, and you'll have to do something to get them. So it's trying to give you a helpful error message here. Hopefully people still read errors nowadays. What it's actually looking for is in this directory here, host injections, which is now a symlink to opt-easy, which doesn't exist in here. So it's trying to find symlinks to the GPU driver libraries there. It can't find them, and it says, okay, you haven't done your homework. So that's the first thing you'll need to do to get that working. Now this is a bit of a weird concept. It's a symbolic link, but it's a symbolic link where you determine what the target is. So it's now pointing to opt-easy, but you can tell CVMFS point this to /temp or something. So you just reconfigure your CVMFS client through CVMFS, etc CVMFS default.local, for example. So in this file, you can tell it this symlink goes there. So you're in full control if you don't want to put stuff in opt. If you want to put it in a shared file system or God knows what, you can actually do that. Now let me be a little bit naughty and actually log into this system. Now let me maybe also show you what happens if you're not being naughty. So in here, GPU support. So this explains it all in detail, what's going on. We're looking at exposing the NVIDIA GPU drivers. That basically means I need to, so we ship the script in Easy itself, right? So you don't need to download it from anywhere. You just need to make sure that this is set, and it should be set because I'm in Easy. All right, so I can copy paste this. This is going to fail pretty hard because it doesn't have write permission. So it's trying to write into this directory. I'm a mortal user here, so opt-easy doesn't exist, and I have no right to create it. So that's what I want to do here. Just quickly by means of showing this off. I won't change the path of the symlink. I'll just give that particular user rights to this. Let me make sure it has write permission, so that should work. So if I now run that same script again, this is going to detect what type of GPU driver I have in my system, what the host CUDA is, not sure why that matters. It downloads this file here from Aptainer, actually. So we're using Aptainer as a source of information here. This is just a list of all the libraries that should be available on your system. That's exactly what Aptainer also does if you start an obtainer container and you tell it, give me access to the GPU, it finds all those libraries, symlinks them, and it's basically doing the same trick as we are, just underneath the covers. And it's telling us that's done. It actually ran, I think, a very quick test as well to make sure that it can actually run a GPU workload thanks to doing this linking. So it not only does the linking, but it makes sure that it actually worked as expected as well. And if we now look into CVMFS software host injections, there's now stuff in here, including stuff for NVIDIA x86, what's on the host, and here there's a bunch of symlinks to paths in the host. So that's working. And this is a bit strange because I'm in a directory here under EasyBuild. So this is a read-only mount of the repository, but because this is a symlink to opt-easy, that's actually where the files are on this particular system. So that's a very nice way of making sure you have some control over injecting something into EasyBuild while still keeping a read-only mount of EasyBuild. But before I get distracted, let me try that load again of CUDA samples. Now it should be happy because I've done my homework. And I can run, what is it, device query, which is coming from EasyBuild. And this should work. So this should be showing what type of CPU I have. So it's actually talking to the GPU drivers to figure this out. So this is working. So in principle, this means that any CUDA workload we ship through EasyBuild should be working because it can talk to the GPU.
And just note that
You should just point out that the CUDA install in EasyBuild also points to the same host injection path for CUDA.
In what sense?
it points down to host injection software CUDA.
You mean in here? So AMD send to CUDA. No, software CUDA. This.
If you do an ls into the one of the libraries there.
Yeah, so these are like NVCC, for example. Let's just focus on this one, the compiler. We don't have the compiler itself in EasyBuild, but it's pointing to a path in host injections because it knows that has nothing to do with the driver libraries. That's problem 2. But yeah, we give you a symlink in here. So if you've done your homework to install your CUDA through the same mechanism, it is coming in through EasyBuild because you're unbreaking that symlink. That's the next step. So that's the second script here. So if you want to make sure your users can do CUDA installations on top of EasyBuild using the CUDA module provided by EasyBuild, you need to run this install CUDA host injections thing as well, and it will basically unbreak this symlink. Yeah, unbreak the symlink by installing CUDA. So this is a bit, I don't want to say nasty, but yeah, this was a lot of fun to figure out, let's say. But yeah, this is the kind of hoops you have to jump through when dealing with commercial software. You have to be very careful. Okay, any questions on that? Let me also clean up this mess because there, it's gone. So now it's broken again. If I now run device query, it's not going to do much. Any questions here? Yeah, Sam? No, there's no stupid questions. This took us a long time to figure out, by the way, so.
So the host injections directory can contain multiple directories and each one is a symlink or?
Yeah, I just threw it away, but yeah, there's a whole structure in there. Yeah. So the scripts that we provide prepare the structure as we know other things expected. So it is a bit of a puzzle. Yeah. Now we're using this in this case for GPU stuff, but through host injections, you can do a bunch of other things as well. And that's maybe also interesting to show. Like how does this device query binary actually know where to pick up the stuff? Is because through our path, device query. So if we just check how this binary is linked, it has a long RPath here, and we should be seeing host injections in here somewhere. Is it? Oh no, in this case, it's not there. No, we have this for MPI software. So let's say the OZU. And now I messed up my environment, I think. Oh no, okay. The OZU benchmarks, and then name an OZU benchmark, P2P. What's the OZU something? OZU scatter, yeah. What I want to show is how we actually prepare the binaries that we ship already to also allow you to inject your own MPI library, for example. So every MPI binary we build in Easy, the first location it looks for the MPI.so, libmpi.so, is under host injections. So if you put libmpi.so there, it will pick that one and not the one coming from Easy. So also through host injections, we allow you to inject your own MPI, for example. I think we're currently only basically doing it for MPI and GPU stuff. But we could be doing this for other things as well. So if you want to get the flexibility to like, I don't like the thing in Easy, I want to be able to use my own, then you can do that too.
Yeah. For example, if you want to open MPI with srun.
Yeah, that's one reason, for
it's
example.
a possible application.
Yeah. Or if you're getting an tuned MPI from your system vendor and they tell you use that, you can, by putting a symlink in that path, essentially, you can make all the Easy software use that as well. Of course, it has to be compatible with what Easy used, so it's not that trivial, but so we have lots of tricks in our hat. We haven't looked at AMD GPUs yet. We'll have to do something similar for that. So we need to get those GPU drivers from the host as well. We won't be able to do that. Sorry? The driver libraries, yeah. No, ROCm we can install in Easy. That's not an issue. But ROCm needs to find the GPU drivers and Obtainer has. Yeah. We can check again what Obtainer did for ROCm and just. Obtainer is open source, so we can steal their ideas, right? That's what open source is all about. Okay. So one more.
From Labour is, I think, the rather than steal.
Inspiration. Yeah. Okay. One very cool thing that Easy enables is using Easy in a CI environment. So if you're running tests for the software you develop, you typically need a bunch of dependencies. GitHub Actions is now getting quite popular for that. So what lots of people do is do pip install in there, or maybe sudo apt install. So typically in a Ubuntu container here, essentially. That may take some time as well before everything is there, and sometimes packages disappear. It's a bit of a mess. But if the stuff you need is already in Easy, you can just use Easy in GitHub Actions as well. And we actually implemented a small action here. So you just tell in this YAML file that you put in your GitHub repository, you say this workflow, this GitHub Actions workflow uses the GitHub action that we provide for Easy, version 3 of that. We want to use this version of the Easy software stack. So this essentially does the initialization part that we do manually. So that source, yada, yada, init bash. It essentially does that. It makes sure that the Easy repository is mounted as well. It will basically install CVMFS in the background. So it does a whole bunch of stuff for you already that you don't need to worry about. So just by adding these 3 lines, all of a sudden you can start loading modules as if they were there already. And whenever you do that, again, CVMFS will pull in everything dynamically as it is needed to run a particular script. So rather than installing hundreds of megabytes of packages, you're essentially just only installing CVMFS, and CVMFS figures out what it needs to pull in on demand to run those tests. What's very cool is that we're seeing this in the wild already. So this is a tool, PyMBE, which needs Espresso. So Espresso is a library where the developers of Espresso are involved in a multi-scale project. So we've installed Espresso in Easy as a way of helping them. And somehow they mentioned that in one of their trainings or one of their presentations. And people using Espresso, so PyMBE has Espresso as a dependency. Rather than figuring out how to install Espresso, they just include Easy in their workflow. They do model load Espresso, and they can run their tests. So also for developers, this helps them a lot. And I know they're testing with essentially the same installation as maybe some of their end users are also using. So it does help to make sure they're testing the correct things as well. There's a link here to that workflow, how it looks like, but it's very similar to what I showed on the slide. So this is in their repository, where they also say here, I want to use Easy. And then it still says here, install dependency. So before they were doing some installation, but now they're just doing a module load. And then maybe, installing their own package. And okay, whatever they're doing here, that seems to be working well. They're running make tests on top of what, on top of the Espresso that comes in through Easy. So for end users, this is or for developers rather, this is very interesting as well. We haven't done this for GitLab yet, but it's going to work just as well for GitLab or for other CI environments. So that makes it very interesting. Yeah.
It's okay. We'll meet halfway.
That is actually a very good example of how to use Easy now. One of the things I was wondering is, would it make any sense to put libraries like FFTW, PETSIG, and all of them into Easy to make exactly that bit much better, instead of focusing too much on the top level software installation like WAMAX, CP2K, and so on? Just go one level below, and then a number of developers already can use Easy for exactly that reason.
Yeah. There's definitely something we can, like I said before, eventually we'll install everything that EasyBuild supports, and that's open source, and we can redistribute. We'll install all of that in Easy as much as we can. Yeah. PETSI isn't there. Was somebody looking into PETSI?
Why are you calling that is a column here. That is a part.
I think we've actually had someone looking into PETSI. I don't know from the top of my head if it's there already, but it is a common dependency. So yeah. And it's a bloody nightmare to install. So that would be very helpful to have it there. Okay. More acknowledgements. Thank you for the money, EU. And yeah, that's it. Okay. Any more questions on Easy?
Hang on. What? Okay. Can you just repeat the reason for having to install the full CUDA SDK into the host injections Symlink?
You only need to do that if you want to compile your own GPU software on top of what's in Easy. So for running it, you don't need it at all. You only need to expose those GPU driver libraries, and then you can run device query or GROMACS or whatever. It's mentioned in the documentation. Maybe I didn't explain that well enough, but in here it says installing full SDK. Do we actually explain it well here? If you want to compile your own CUDA-enabled software, then you need the CUDA compiler in some way, right? And since you're getting the runtime through Easy, the best thing you can do is also getting that compiler through Easy, but indirectly through that Symlink mechanism.
Yeah, that's what isn't clear to me from the description. What is the CUDA module in Easy doing if you need to install CUDA into host injections?
So if you're only running stuff that's included in Easy, you don't need the full CUDA. So we give you the runtime parts of the CUDA installation. So if that CUDA samples thing was running before, I never ran this script. So I never installed the full CUDA. I only made the connection to the GPU driver libraries, and that was enough. So the runtime stuff we can ship in Easy, and we do. The compiler we cannot. So if you need to compile your own stuff, you have to provide that.
Okay, so license reasons to not ship NVCC.
Yes. Exactly. The EULA doesn't allow to redistribute NVCC. In the EULA, they have like a list of paths, like these things you can redistribute, anything else you cannot. And we, in our EasyBuild hooks, we scan the EULA, we get the paths, and that's the only thing we ship. Because we want to make sure that we don't accidentally ship something we're not supposed to.
Okay, just imagine it's gonna be very confusing for users because this sentence here is sounding very easy. Choose the CUDA version according to the CUDA versions included in Easy. Well, second paragraph
Here,
below. Yeah. So you're installing NVCC from which CUDA version if there are like 3 different CUDA versions in Easy? And what does the user get then?
Here, so this part, you have to give the CUDA version here, the one that you want to also compile with.
Yeah,
Right.
but then the user basically has only one specific version available, right?
No, so if you can do multiple CUDA installations under host injections. The script is smart enough, it puts them all in their own directory.
And the CUDA module then goes into this host injection path and loads the correct CUDA compiler.
Yeah, it's like I showed, the NVCC symlink here is into a versioned path for CUDA. So the symlink under CUDA 12.1.1 links to host injections CUDA 12.1.1. Yeah. So it's version,
Okay,
it has to be version specific. Yeah.
Makes sense.
You can have 100 CUDA versions in here. That's fine. You can install stuff in there that's not symlinks from Easy yet. That also works, right? You're just unbreaking symlinks.
Okay. Yeah. I was afraid that it makes it very hard for users to use, especially as NVCC is very different across versions and what it is
we are aware
with. Yeah.
It has to be linked to specific versions, or in practice, it's not going to work. Yeah.
Okay,
I mean,
perfect.
I do agree. This stuff is still confusing, but it's as easy as we can make it, I think, except if we do more tooling around it. But in terms of this is the absolute minimal stuff we basically have to do to be legal.
Okay. Maybe that sentence could be made more clear in saying that you can do this for multiple CUDA versions, not CUDA version singular.
Yeah, that's true. Yeah, we can definitely reword that. Yeah. Yeah, if stuff isn't clear, let us know and we'll happily take your pull request and merge it. No, we'll take your feedback on this as well. We're already happy that this was like a hard milestone that we had to hit before the end of last year. I don't want to say it's a rush job, but we're happy that we were able to get this in the docs and basically hit that milestone, that we didn't run into trouble. It can definitely be improved. Yeah. There's a lot of work behind this, especially the scripts. There's a lot of checking if else and a lot of testing and retesting. This was not that trivial to do. Okay. I think we can wrap up. We have one more talk coming up. And we can stop the recording, stop the stream. We should turn this one again. Or bring it here.